Sweet potatoes are more than just a delicious Thanksgiving side dish. They are a major agricultural commodity in the United States. Grown primarily in warm weather states like North Carolina, Mississippi, and California, sweet potatoes require specific climate conditions, careful planning, and precise harvesting techniques. In this in-depth video, we will take you on a journey through the fascinating world of sweet potato harvesting from the moment they're planted in fields to the time they are cleaned, sorted, stored, and finally sent to stores across the nation. The rise of the sweet potato in American agriculture. Sweet potatoes have deep roots in American agriculture. Over the last few decades, consumer demand for healthier and more versatile food options has fueled a dramatic increase in sweet potato consumption. Known for their high nutritional value, rich in fiber, beta-carotene, and vitamins, sweet potatoes are now used in everything from fries and chips to baby food and pet snacks. North Carolina leads the nation in sweet potato production, accounting for over 60% of the U.S. supply. Other major producers include Mississippi, California, and Louisiana. The harvesting process of sweet potatoes is both labor-intensive and mechanized, blending old-fashioned farm wisdom with state-of-the-art machinery. Step 1. Preparing the soil and planting. Before sweet potatoes can be harvested, there's a long process that begins months earlier with soil preparation. Sweet potatoes prefer well-drained, sandy loam soil rich in organic matter. Fields are plowed and ridged to create raised beds which improve drainage and root development. These beds are usually 8 to 12 inches high and spaced about 3 feet apart. Unlike many crops that are grown from seed, sweet potatoes are propagated from slips. Slips are vine cuttings that sprout from mature sweet potatoes. These slips are hand-cut or mechanically sliced from seed roots grown in special nurseries. Once harvested, the slips are immediately transplanted into the field, typically in late spring or early summer. Transplanting is often done with the help of specialized machinery that punches holes into the beds and inserts each slip into the soil, ensuring consistent spacing. Some smaller farms still rely on manual labor for this step, but the mechanized approach is more common on commercial farms. Step 2. Growing season and crop maintenance. Sweet potatoes are a warm season crop and require a frost-free growing period of 90 to 120 days. During this time, farmers carefully manage irrigation, weed control, and pest prevention. Weeds are a major concern, especially in the early stages of growth, so mechanical cultivators and herbicides are often used to keep the beds clean. Pest control is another crucial element. The sweet potato weevil is a notorious pest that can devastate crops if not properly managed. Integrated pest management, IPM, techniques, including crop rotation, pheromone traps, and biological control, help reduce the need for chemical pesticides. As the vines grow and spread, they cover the field like a thick green blanket. These vines help protect the soil from erosion and suppress weed growth naturally. However, they also make it difficult to monitor the health of the root systems below. Skilled farmers must interpret subtle signs in the vines to estimate the readiness of the crop. Step 3. Timing the harvest. Determining the perfect time to harvest sweet potatoes is part science, part intuition. Farmers typically begin harvesting 90 to 120 days after transplanting, depending on the variety and climate conditions. Too early, and the roots are small and underdeveloped. Too late, and they may crack or suffer from internal disorders. Most growers use test digs, pulling up a few plants from different areas of the field to assess the size and quality of the tubers. Once a majority of the sweet potatoes reach market size, about 2 to 3 inches in diameter and 6 to 9 inches in length, harvesting begins in earnest. Weather plays a critical role in harvest timing. Sweet potatoes are extremely sensitive to cold temperatures, and even a light frost can damage the crop. Therefore, harvesting must be completed before the first frost hits the region. In states like North Carolina and Mississippi, that usually means wrapping up by late October. Step 4. The mechanical harvesting process. Gone are the days when sweet potatoes were harvested entirely by hand. Today, large-scale farms rely on specially designed harvesting equipment to lift the tubers out of the ground efficiently. The most common machine used is a chain digger harvester, which is pulled behind a tractor. As the machine moves along the row, a blade slices beneath the soil, lifting the sweet potatoes and feeding them onto a chain conveyor. The conveyor gently shakes off loose dirt and delivers the tubers to a sorting platform or directly into a bulk bin. Despite the machinery, the process still requires a human touch. Workers walk alongside the harvester or ride on the machine, manually inspecting and sorting the potatoes as they emerge from the ground. Misshapen, damaged, or undersized tubers are culled on the spot. Some farms use semi-automatic harvesters that require manual collection of the tubers into crates, while high-tech operations use automatic bin fillers that reduce the need for handling during harvest. Step 5. Post-harvest handling and curing. Once harvested, sweet potatoes are still far from ready for store shelves. Freshly dug tubers are fragile and susceptible to bruising and decay. To prepare them for long-term storage and shipping, they must go through a process called curing. Curing involves storing the sweet potatoes in a warm, humid environment, typically 85 to 90 DEF with 85 to 90% humidity, for 5 to 10 days. This process allows small wounds to heal and convert some of the starches into sugars, enhancing their sweetness and shelf life. Curing is done in specially designed barns or climate-controlled storage units. Some farms have invested in high-tech curing rooms equipped with automated temperature and humidity controls to ensure optimal conditions. After curing, the sweet potatoes are moved to long-term storage areas where they can be kept for several months under cooler, drier conditions, around 55 DGF with 85% humidity. This extended storage window helps farmers spread out sales and meet year-round demand. Step 6. Cleaning, grading, and packing. Before sweet potatoes make their way to grocery stores, they must be cleaned, sorted, and packaged. In large packing facilities, tubers are conveyed through a series of stations where they are washed to remove any remaining soil. Mechanical washers use soft rotating brushes and water jets to clean the potatoes gently without damaging the skin. Next comes grading. This is where sweet potatoes are sorted based on size, shape, and quality. Advanced systems use optical sensors and conveyor belts to detect imperfections and automatically categorize the tubers. Grade A sweet potatoes, uniform in size, free of blemishes, are packed for fresh retail sales. Lower grade or misshapen ones may be directed toward processing, like frozen fries or puree, or used as animal feed. Finally, the graded sweet potatoes are packed into boxes, bags, or crates depending on their end use. Labels are applied with details like origin, weight, grade, and barcode for traceability. These packages are then loaded onto refrigerated trucks and shipped to distribution centers and supermarkets across the country and even internationally. The role of labor and automation. While mechanization has greatly improved efficiency, sweet potato harvesting still relies heavily on human labor. Thousands of seasonal workers are employed each year to help with planting, harvesting, sorting, and packing. In regions like North Carolina, migrant labor programs play a vital role in supplying the workforce needed during peak season. However, labor shortages and rising wages have pushed many producers to invest in automation. Some companies are testing robotic harvesters equipped with computer vision and AI to identify and pick tubers without damaging them. While these technologies are still in the early stages, they offer promising solutions for the future of sweet potato farming. Sustainability and environmental impact. Modern sweet potato farming practices are increasingly focused on sustainability. Farmers use precision agriculture tools like GPS-guided tractors, drones, and soil sensors to optimize fertilizer use, reduce water consumption, and minimize pesticide application. Crop rotation is another key strategy. Sweet potatoes are typically rotated with grains or legumes to reduce disease pressure and improve soil health. Cover cropping and reduced tillage also help conserve topsoil and boost organic matter. Moreover, many farms are exploring zero-waste strategies by turning lower-grade tubers into biofuel, pet food, or compost. These efforts not only reduce environmental impact but also create new revenue streams. Economic importance. Sweet potatoes contribute significantly to the rural economy. In 2023 alone, the U.S. produced over 3.2 billion pounds of sweet potatoes, with an estimated market value exceeding $700 million, 0 cents. North Carolina alone produced more than 1.8 billion pounds, making it a global leader. Sweet potatoes are also a vital export commodity. Countries like Canada, the UK, and the Netherlands import large quantities of U.S. sweet potatoes, attracted by their quality and consistency. This growing export market has encouraged more American farmers to adopt stringent quality control and food safety measures. Challenges in the industry? Despite their popularity, sweet potato farmers face several challenges. Climate change is a looming threat, as erratic weather patterns, including excessive rain or drought, can ruin entire crops. Soil-borne diseases like nematodes and fungal infections are another persistent concern. Labor availability is also becoming a bottleneck. As immigration policies tighten and fewer workers are available for seasonal farm work, the industry must adapt quickly by embracing automation and better working conditions. Transportation costs, packaging waste, and market price volatility further complicate the supply chain. However, through innovation and government support, the industry continues to evolve and overcome these hurdles. The future of sweet potato harvesting. The future of sweet potato harvesting in the U.S. looks promising. Innovations in biotechnology, such as disease-resistant varieties and faster maturing crops, are helping farmers achieve higher yields with fewer resources. AI-driven farm management platforms are making it easier to track planting schedules, pest outbreaks, and weather patterns. On the harvesting side, fully automated systems with smart sensors and robotic arms may soon reduce the need for manual labor entirely. Meanwhile, sustainable farming practices are becoming more widespread, ensuring that sweet potato production can remain both profitable and environmentally friendly. Consumer trends also suggest continued demand. As more people adopt plant-based diets and look for natural, nutrient-dense foods, sweet potatoes are positioned to be a long-term staple in kitchens around the world. The journey of a sweet potato, from a tiny slip planted in sandy soil to a vibrant tuber on your dinner plate, is nothing short of remarkable. It involves months of planning, hard work, cutting-edge technology, and a deep respect for nature's rhythms. As American farmers continue to refine their methods and embrace innovation, the harvest of millions of sweet potatoes each year will only become more efficient, sustainable, and impressive. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.